number 11 here is the last one that I'm doing for examples for the trig section here. This one only uses the law of sines here. And the reason we know that we're just using law of sines is because we have an angle and a side opposite of that angle this time, because this angle is opposite of that side. But once again, we can't just use our SOHCAHTOA, we can't just use the sine, cosine, and tangent again because it is not a right angle. So it's not a right angle for your triangle, then that means that you have to use either law of sines or law of cosines. If you have an angle and an opposite side already given to you for the values, then you could already use law of sines, and you don't have to use the law of cosines first like we had to do for number 9. So here, once again, what we have is A over sine of A, which represents our side, and the angle opposite of that is equal to our side B over sine of B, and so on for each of those sides and angles. So the little letters, the lowercase, remember, represent the sides, uppercase represent your angles, and it's always the angles that go with your trig function. So here in this case, for instance, we could set this up as 2 over our sine of 20 degrees is equal to, and then we have 3 over sine of the angle opposite of that. So let's call that angle maybe angle X. We'll call this maybe angle X, and we could call this one angle Y, and maybe we'll call this side Z, just so that way we can label those, since they were already labeled in the triangle. So we'll call this sine of X. Really doesn't matter what letter you give it if it doesn't already have a letter assigned to it. You can name it whatever you want. If you wanted to, you can label it B instead if that helps you to remember it better. Then it's a matter of going through and cross multiplying again. So we'd have 3 times our sine of 20 degrees is equal to 2 times our sine of X. Once again, the parts with the X we want to get by itself, so we want to divide both sides by 2, the part in front of our sine of X. So that'll get rid of this 2 part here. Cancel out the 2's, but then to cancel out the sine, remember we then have to do inverse sine. So we also need to then do, after we already cancel out the 2, we need to then do the inverse sine of both sides to get it so that way we have just the X rather than the sine of X there. So here we have inverse sine both sides. Once again, inverse sine this time because we had a sine function there. And then it's a matter of going through and get all of this entered into your calculator. Once again, depending on your calculator, depends on exactly how you'll enter that in. So if you do get stuck and have questions on how to enter any of this, make sure that you're asking in class, because it varies depending on what type of calculator you have. So we'd have inverse sine of our 3 times sine of 20 degrees, and then divided by 2. So it looks like here for our angle for X, we get approximately, controller likes to go a little bit out of whack here sometimes. Alright, so our X is approximately 30.87 here, degrees, because we're dealing with a degree angle here. So that would be for that top angle, for the one I labeled as X. So then to figure out our third angle, remember once you have 2 angles, you can do 180 degrees minus the 2 that you already know to get that third angle. So this will give you your angle Y here. So here if you do 180 minus 20, you'd have 160. And then if you subtract another 30.87 there, looks like we get about 110 129.13 degrees there. So that would be for angle Y. So now we have both of our angles that we're missing, using our law of sines, and then using that our angles have to add up to 180 degrees. But then we still have to figure out our side Z here. So here in this case, we will use law of sines again. So I'm just going to box in what we had so far so that we keep those separate. We had our X, and then we had our Y over here. So then for Z, we can go through and do the same sort of thing as what we did to figure out our angle X, except for this time it's the side we're finding. So we're going to put Z on the top here, since that's a side, divided by sine of the angle opposite of that. So remember, it's not necessarily always labeled exactly the same in terms of A's and B's. It's always the side and then the angle opposite of that. So the angle opposite of side Z is our angle Y that we just solved for, 129.13. So it's easier to try and think of these in terms of how they relate on the triangle rather than in terms of the letters, because the letters will change depending on the problem. And then we still have the 2 over sine of 20 degrees that we had before. As the 2 and the 20 degrees are opposite of each other. And remember, the angle measure always goes with the sine function. And then you would cross multiply like before. So here we have Z times our sine of 120 degrees. You'll notice this time the variable is not in the sine function. So we do not have to worry about doing an inverse sine here. We only have to do that if your variable is inside that sine function, if it's after that sine function there. So make sure that you're writing those out correctly as well. So we have 2 times sine of 129.13 on the other side there. And then we're going through and dividing both sides there by sine of 120 degrees to finish getting Z by itself. So those cancel. So then here, no matter going through and getting this entered into your calculator, the 2 times sine of 129.13, and then dividing that answer by your sine of 20 degrees here. So here it looks like we should get approximately 4.54 here. And then remember, our sides in this case are in terms of meters. So we would have meters there on our 4.54. And make sure that you're always labeling these in terms of which ones are in degrees and which ones are your lengths. In this case, the length is in terms of meters. Make sure that you are going through and practicing entering those into your calculators. Some of your calculators, it's a little bit harder to enter these into than others.